Lad være.
Jeg kan tage det på alt.
Jeg forstår ikke det der med dig.
Peter, du vil gerne snakke, ikke?
Der er ikke andre, der kan godt sige på.
Altså sammen med Emil.
Jeg kan godt sige på.
Jeg skal altså helt over, hvis du...
Vi skal egentlig bare lige holde den i gang, indtil vi får lavet en fire.
Jeg tænker ikke, at det er ikke sådan, der behøver at være en nødvendigvis, der tager det hele.
Nej.
Jeg kan da godt lige komme på
Perfekt. Jeg tænker, vi skifter lidt ud, ikke, med Amalie som center person, der styrer the ship. Så kan man...
Det ser jeg den pæneste.
Hallo?
Jeg er jo ikke fornærmet. Jeg sætter pris på komplimenter, selvfølgelig gør jeg det.
Hvor stor er vinklen? Hvor meget kan
Ja, jeg tror nok, I skal rykke.
Kan I se pavillonen? Det grønne ansvar. Fordi så kunne vi sætte den der op i metallet måske.
Ja, det er sådan, det skal være.
Nej, det ved jeg godt.
Det kan vi ikke.
Det kan vi ikke, okay.
Hvad så med mig?
Du kan også være en kamera.
Jo, hvordan først I stoppe så?
Inden vi går live, så gør vi godt lige om lidt.
Sådan der.
Kan vi lige aftale nogle emner, vi kan snakke om?
Hva?
Inden vi går live, så gør vi godt lige om lidt. Men inden vi trykker send, så kan vi lige aftale nogle ting, vi kan snakke om. Og så kan jeg lige poste det der link alle mulige steder.
Hvad der sker, det er nok nummer 1.
Ja.
Er det muligt, vi kan starte en skjult stream for lige at afprøve det også?
Ja?
Kan det muligt, vi kan prøve at starte en skjult stream for lige at
Ja, kan vi starte en skjult stream lige hurtigt? Kan vi starte en skjult stream lige hurtigt? Okay, kan jeg hoppe på her? Vil du sende linket? Et andet bare så jeg kan se det, hvis jeg går lidt væk.
Ja, det kan vi godt.
Hold nu. Det er den ved på noget. Helvede. Ej, det er helt galt, det stiller ved ikke. Den ligger ikke her. Nå, det er en killing. Nej, den burde ligge her.
1 minute!
Ja, men vi må lige vente med at gå live, så vi er klar, synes jeg. Der er ikke nogen grund til at vise folk, at vi ikke har styr på vores shit.
Hvad på jeg med?
Vi har overhovedet ikke styr på vores shit.
Far, det var linket. Er det bare sendt det til Hasse?
It works!
Der kører det ikke nu.
Og hvor? Ser du linket ligger?
Slack!
Hvilken kanal?
Everyone, det
Jeg ved ikke, om vi skal mute det her faktisk, så man ikke kan høre det.
Ja, ja.
Nå. Vi kan jo bare starte den op.
Nej, skal vi lige vente et øjeblik, please? Nå, vi kan godt starte den op.
Altså bare hvor
Vi bliver
DanSTAR
med at sende
filter
det
af over.
nogle steder.
Må jeg godt lige låne linken på din kamera?
Ja, endelig.
Fuck.
Den skal være højere op og større. Den er på.
Jeg skal nærmest sænke mit kamera lidt så.
Sådan der.
Altså,
Ja. Det er lige meget.
ja.
Det skal engelsk.
Engelsk.
Ja, det skal.
Modtaget. Så har vi hårdt siddet ordentligt. Nogenlunde præsentabel. Ja.
بعد رفع تعال تجيب مكان تشوفه انا ما عندي وقت هسه بعد رفع سويت
Tror I, det er en god idé med at skætte der?
انت وين
Nej.
Bop.
تشوف تصميمك كلها احمر هذول الفايت
Okay. Sæt den,
Der er hul på, der er hul på.
okay.
Der står sprøjter. Ja, der er hul på den sprøjter til hjertet.
Nå, ja.
نشوف الراكيت يمسكوا بين البابل
Ja.
Absolut.
Okay, kan vi få en DanSTAR stikker, venner?
لا لا هي هاي هايلا كانوا يستعملوه بالبايع بعد
Du vil gerne ligge i en af de her kasser, så ligger det i en lille pose.
يا ستريم يلا باي استعمل اذا تستعمل جوجل يطلع لك ريجستر Bygning. Rephalsø. Rephalsø. Bare skriv Rephalsø. Jeg sender dig den, eller bare.
All of them.
Ej, det er fint. Skal vi ikke finde dem, eller hvad? Nej. Vi mangler ikke stikker.
Jeg ved ikke, om det er bedre, du sender der andet sted.
Jeg skal nok være med noget.
Det er godt chok.
Det sker, det kan jeg godt.
Har du...
Det var dumt. Så Amalie, er det min?
Nej, det er... Stefan.
Skal vi bare starte den, og så bare
Nej,
tage den?
nej. Jeg skal lige finde stikker til min computer. Nej, ikke sådan her. Jeg tror, vi starter, så må jeg få den der stikker senere.
Ja, jeg går ind til serien, så kig. Hvis jeg har det i kassen der.
Det ligger i en plastikkasse, men hvor er den plastikkasse?
Jeg har set dig ude på serien. Skal vi ikke det?
Er det ikke en af jer, der vil gøre det, så kan vi lige snakke om, hvad der skal ske. Altså, er det muligt for at gå ind til CS? Eller også Sara? Ja, det ligger i sådan en... det ligger i sådan en lilla, sådan en lille Windows 4. Så ligger der sådan en finance... Har du også set i købpladsen? Okay, vi skal snakke om, hvad der foregår nu her. Det er static fire, og hvad det ligesom betyder. Skal vi snakke om de issues, vi har nu? Eller?
Ja, eller måske fortælle lidt om, hvad vi er kommet. Hvad er vi kommet her til?
Så noget historien?
Ja, historie. Ja, historie. Vores historie for at komme til. Måske noget...
Så vi har haft en teststand, som vi har lavet hotfires på.
Jeg tænker måske noget med konkurrencen i stedet, hvordan det bliver aflyst, eller hvordan vi skal skabe nogle nye forbindelser. Ja, det med forbuddet ikke, og hvordan det går nu. Jeg tror, vi kan få nogle andre folk ind og snakke lidt.
Ja.
Adam, are you up to do a little interview later? Talk about the electronics.
Just talking about electronics.
Sure thing. Can I show my dick?
Yes, of course.
But we're gonna go live in like 1 minute. So.
The girlfriend says no.
Okay, so I will try to put it into a presentable shape.
Ja. Men ja, jeg tror egentlig bare det er det.
Mange gange kan man ikke se spillet. Og ligesom kan se det bare
That's what you get for being a dick.
If I die because of it, I deserve it.
Okay.
Vi bare kan live, og så bare sidde og vente på.
Ja.
Oh,
Skal vi dele det der link nogle steder og sådan nogle ting?
Ja, det er
Men kan jeg få det også, så jeg kan dele det? Ja. Men der står private stream. Færdig. Der står private stream.
Vi går live nu. Bare lige så ikke det kommer. Hvem er vi streamer herovre, så bare...
Altså, kan vi ikke lige tage et billede, og så kan vi lægge det op som vores livestream? Du lige sidder der her, så ligner vi sidder to og hygger. Altså, vil du tage et billede af os?
Jeg er ikke til at sidde der.
Du kan jo ikke sige noget, du skal bare sidde der og gøre noget ved siden af mig.
Det var hurtigt.
Ja. Så fint.
Ja.
Vil du sende det til mig på Facebook? Så er vi lige lynhurtige her.
Nej, jeg har sendt det til dig.
Nikkel?
Ja.
Ja.
Så vil lige lægge det op på Facebook.
Det var planen, ja.
Nu er det der. Jeg er inde på den lukkede gruppe, ikke engang noget at gøre på det officielle.
Okay, det er fint nok, jeg sidder med min computer her.
Ja, det er fint. Ja, der er ikke noget.
Casual.
Ikke cash.
Just so that you know, like it's recording everything. They can hear you all.
Fuck nu af.
Yeah.
Ja, nu
No,
kommer
no bad jokes.
Ser du?
der er en konkurrence.
Nice. Mission pass. Var du okay i vinkel?
Hej. Var det svært at finde det?
Har du startet nu, Freddy?
Ja, ja, fra det.
Skal jeg skrive andet end bare, at vi er live?
Ja, altså bare skriv vi live. Altså den kører nu, så du er live.
Kan du se, om der overhovedet er nogen, der...
Altså bare det vi snakker om nu, det
Kan du se overhovedet, om der er nogen, der...
Der er 3 seere.
det er
Nå,
tre.
nice.
Jeg tror, nogen ligger nok, så...
Ja, der er en af dem i hvert fald.
Så har jeg ikke den ene anden, der er med et eller andet sted.
Kan du... Ej, det er nok også. Jeg ved ikke, hvad der er.
Det er mig.
Så er der 4. Amalie, er det ikke muligt at have stream kørt på din computer også? Fordi så hvis du kender på live-chatten, så kan folk eventuelt stille spørgsmål.
Hvor ser jeg, der står chattet deaktiveret?
Ja, så er det Freddy, der skal...
Freddy, kan du lige aktivere chatten?
Det har jeg aldrig prøvet.
Der står deaktiveret på denne livestream. Så kan du ikke snakke med os.
Det handler jo om lige hvor det, hvordan vi bliver stuck eller sådan noget. Er der mad? Er der kommet mad?
Ja. Banen har flyttet mig der. Jeg kan ikke se på, den er varm længere.
Det gør ikke noget.
Kommentarer er også slået fra. Det må bare ikke snakke til folk.
Ja, der vil lige faktisk et nyt bil, og man kan sætte på snakken. Det skal ikke jeg har fundet noget, der ikke
Men det er fint nok ikke at skifte over til Mission Control video på den tidspunkt, ikke?
Ja, så står man bare sådan.
Så vi sidder her og snakker lidt, og så sætter vi det over til det. Ja. Lavede en Facebook-post. Skal jeg lave den på LinkedIn også, eller hvad?
Lige op, ja.
Jeg tror, der er også noget med, at det er, når vi snakker biler,
Vil du tjekke, om det virker på Facebook, det link, jeg har delt?
Det virker med en Facebook-link virker.
Okay, super. Tak så godt.
Så sætter det bare fast i den næste. Nej. Ja. Det kan man ikke klage over, så. Eller hvad?
I mean, the first guy
No, no, it's okay.
Okay.
Yeah.
Jeg kan ikke live-chatten er decideret. Så nu kom.
Okay, det virker nu ikke. Det er ikke noget. Der er ikke noget der. Amalie, det kører bare.
Super.
Yes.
Bør vi have langsom tilstand? Er det ikke lige meget? Godt. Det var fedt. Helt vildt så pres.
Så ni der nok her.
Simpelthen. Jeg skulle gerne foregå noget livestream lige med.
Helt dernede fra?
Nej, sådan lige der.
Sådan der.
Jeg ved ikke rigtig, kan vi se, om der overhovedet er nogen, der sådan... 15? Er det nok til, vi gør med?
Ja.
Cool. Men skal jeg bare gøre ting? Vil du være med? Du må ikke sige noget.
Okay.
Nej. Fint nok. Godt. Skal jeg få kameraet en lille smule tættere på måske? Det er bare fordi, jeg bliver lidt forstyrret af, at der sker så meget i baggrunden.
Ja.
Nu er der jo super meget delay på her. Jeg kan ikke se, hvad vi kan ændre noget. Hvor lang tid delay er der på det her? Ja, det var min, der er langsom. Okay, men lad os håbe på, at der...
Der er sådan 5 sekunder mere.
5, okay.
Cirka.
Men hvor mange af de der 15 er bare os selv? Ja, vi har jo ikke nogen technical difficulties. Skulle jeg også bare spørge? Yeah, good. Hey everyone, if anyone is out there following our live stream, can you maybe send us a message or a chat in the live chat function so we know that you're there and it's not just our people looking at the live chat or the live stream? Sker ingenting. Jeg tror jeg tror altså kun det er vores folk, der...
Der må vi jo bare køre. Sådan er det.
Okay, vi har en med. Super. Hej Daniel. Vi kan også bare køre shoutouts til folk hele dagen, dem der ser med. Nå, men skal vi ikke bare gøre det alligevel? Okay. To whoever is watching, I'm just gonna, my name is Emily, first of all, thank you for tuning in. I'm gonna explain to you a little bit about what we're doing today at this static fire, also called a vertical test of our rocket Dragonfly. I'm gonna talk to you a little bit about the history, how we made it this far, and the plans that we have in the near future. So as I mentioned, this is called a static fire, and it means that we basically have the rocket vertical and doing a test of all the systems, all the subsystems, except for the flight itself. So basically switching on the rocket and holding it down really tight so it doesn't go anywhere. We tested last weekend as well and yesterday, and we've had some pretty successful burns so far. One test is called One Burn because it burns. Nice. And we've actually shared a few of these clips on our social media pages these last few days. So if you haven't seen them, then you can tap away from this live stream for a second and see that, because it's pretty spectacular and it will give you an idea of what's about to happen later. But yeah, so we've spent just about 2.5 years on this project itself. I started out by building a test stand and a demonstration engine and iterating on the data we got from that. And now we have a 3D printed rocket engine in steel, the first of its kind in Denmark, which is pretty sick, if we may say so ourselves. It's 3D printed in collaboration with the Danish Technological Institute. So we like to think of ourselves as kind of a little poster child within the 3D metal printing community as well. So we started out by, of course, making a lot of tests on the demonstration engine. These tests are called hotfires. We've shared a bunch of tests and videos from this back in the beginning of this year, back in January and February. We had about 2 months where we had tests every weekend. So pretty intense, but it also paid off. And now we have the rocket engine that's actually in the rocket and supposed to go on the flight with the rocket. And these are the last stages of our testing. So we're set to go to Portugal to launch the rocket in just about 2-3 weeks. We were supposed to go to the US for the competition Spaceport America Cup, but it got cancelled along with everything else fun this year. We were supposed to go last year, but we decided to postpone it to this year to conduct the necessary tests that we were in doubt we could actually make in the time we had left last year. So yeah, now we're going to Portugal instead for a competition called European Rocketry Challenge. Yeah, European Rocketry Challenge, also called Euroc. They have a bunch of new social media pages because it's a very new competition. It's actually the first time that it's conducted. So go ahead and give them a follow as well. So right now we're waiting for the test to be... guys, can you maybe talk somewhere else? Altså, kan du lige få folk til at gå lidt længere væk? Det styrer helt vildt meget. Thank you for the information. Sorry for the background noise. We're trying to get a hold of that. Yeah, please let us know if it's still a disturbance. We can remove people if necessary. Okay. But yeah, right now we're waiting for the last preparations to be finished to do the first burn of the day. That's actually what you can see behind me. The large concrete block to the side of my head is thank you. The large concrete block here is is where the rocket is currently strapped tight. And yeah, so that's where the rocket is strapped tight, and it will be there for the rest of the duration of the day. So you won't be able to see the exact angle from here, from the test, but we have a similar camera to this one right in front of the rocket actually, so you'll be able to you'll have the best seats in the house basically to the view of the test. Of course, one important thing to mention is that we actually have water cannons and like fire safety equipment like on site. So in case anything happens that is not intentional, we have the means to solve the situation on the spot. We have a guest in the studio. Hi. Would you introduce yourself and what you do in DanSTAR?
Yeah, my name is Peter, and I'm part of the mechanical team. So I've been fixing a lot of small mechanical issues on the rocket, for example, like mounting cameras and mounting different things on the rocket. And I've also been working on the recovery system,
which is of course very important. Something I didn't mention earlier, but there is a parachute, you should call it.
Yeah.
Because in the rocket.
Because we have invested so much time and effort in this rocket, we don't
and
just
money.
And money. Thank you to all our sponsors. So we don't want it to just fall down and crash and burn. We wanted to get it down in one piece. And in order to do that, we have a recovery system, and the way it works is that once we hit apathy, someone else wants to use the highest point of the rocket, the side of the rocket, then we eject the nose cone, so we pop it off. We are popping some CO2 canisters, and then the pressure builds up inside the nose, and that pops it off. Okay, and once the nose cone has been popped off, then a small parachute deploys, and then we fall with that small parachute, which we call the broke parachute. We fall with that until we are at an altitude of 500 meters, and then we have a mechanism that deploys a big parachute.
Really big. We actually tested it right here on this site. In case you can't recognize the surroundings, this is Refshaleøen, which is where Copenhagen Suborbitals also have their headquarters. Copenhagen Suborbitals is kind of our big brother. They build, I guess you can say, larger scale.
I would not say our big brother, I would just say our brother.
Yeah, just brother. They are currently building or working on building a rocket used for manned flight to space, which is a bit bigger scale than what we do currently. So our rocket is supposed to hit 30,000 feet, or around 9.1 kilometers, which is a distance that is kind of set by the competition we were supposed to participate in the US. So that's why we chose that exact height, I guess. And we're supposed to hit that pretty precisely or pretty accurately, not too much higher or not too much below, but pretty much on the spot there. But yeah, we tested the parachute right here on the Refshaleøen, because right behind this camera, so you can't see it unfortunately, but you'll be able to see it later, there's a huge, what do you call it?
Building.
Huge building, en stor hal, where from the roof we could throw out the parachute with a weight in, so we could see if it would fall and open as it should.
Yeah, and see that all the lines and should be tangled together into one big mess, but that everything is kind of deployed nicely.
Because parachutes are a whole science in and of its own. Just the science of packing a parachute optimally is a pretty difficult endeavor, but extremely important for the safety of the rocket on the way down, of course. Yeah?
I don't know, is it on the agenda to maybe give a tour of the actual pad?
Yes. But we'll of course show you the what Peter is asking, if we're gonna give you a tour of the area where the rocket is later, and we are, of course. But right now too many preparations are going on, so we'll show you after the test that we'll be doing. So don't worry, we'll be able to see everything. But later on there will be an extra little video snippet of from the cameras near the rocket. Yeah.
Have you explained what's going on right now?
Yeah, I've explained kind of what the deal is with the static fires. That is to test all the systems and everything except the flight.
What about like the issues we're having?
I have not explained the issues yet. Maybe you can explain that more in depth than I can do.
Yeah. So optimally, we would already at this point during the day have had several burns. But
like I mentioned, one burn is one test. That's what we call it as a burn.
But unfortunately today we're having some annoying issues. And specifically we're having issues with the nitrous oxide tanking.
So nitrous oxide is one of our fuels, actually.
Yeah, we use nitrous oxide as the oxidizer for our rocket, and then we use isopropyl alcohol as the fuel. And then when we mix that, we get a very energetic combination.
It's important because if you think about it, the rocket engine is much similar, or kind of similar to, like if you compare it to a car's engine, for example. During a car ride, you get air in from the outside, but when it's a rocket, you need all the oxygen already in the rocket, because you can't suck in air on your way up in the rocket. So where a car can get the oxygen from the air outside, we kind of need that in the rocket as we launch. So that's why we have the oxidizer.
Yes, but the thing we're having issues is the nitrous oxide tanking. And the way the tanking procedure works is that we have some bottles which we buy commercially, and then we move those over next to the rocket, and then we have a hose which we connect to the rocket, and then we start tanking nitrous oxide into the tank on the rocket. But in order to prevent the nitrous oxide from running back out of the rocket, when we disconnect the filling hose, we have a check valve, and that's the thing we're having issues with. The check valve is malfunctioning, so when we have tanked nitrous oxide and we are disconnecting the hose that we used to fill with, then the nitrous oxide just runs out again. So right now we have dismounted the check valve that's malfunctioning, taking it to the workshop, and then we're trying to repair it, and then we reinstall it, and then we can hopefully start tanking nitrous oxide.
So hopefully it won't be too long. We actually have had this issue already yesterday. Yeah, yesterday. So hopefully we know how to fix it more efficiently this time around. But that's the beauty of testing. That's when you find the little hiccups that you don't want to encounter on launch day in Portugal, of course. Yeah?
The hypothesis is that the reason the check valve is malfunctioning...
Can you explain just briefly what is a check valve?
Yeah, a check valve is, it's also called a one-way valve. So it means that fluid can run through in one direction, and it cannot run the other direction. So that means that when we are, just to explain like the exact setup we have, if we have the tank, imagine that this red pole is the tank on the rocket for nitrous oxide, and then this is the tank or the bottle that we store the nitrous oxide in outside of the rocket, and we want to transfer the nitrous from this tank to the rocket. So then we have a hose that connects to the tank, and then we also have a check valve on the same line here. And the smart thing is that when we are done tanking and when we disconnect the hose, then the check valve, because the fluid can only run one direction from the bottle to the rocket, and then when we disconnect it, it will not just run back. So a check valve is just a one-way
valve. Say that sometimes fast.
One-way valve.
Yeah. Okay. So hopefully we'll get that sorted soon. Yeah. Thank you so much for your explanation.
Thank you for having me.
Thank you. But yeah, I think as Peter mentioned, we of course also need to thank our sponsors. I don't know if anyone on the stream are actually from any of the sponsoring companies, but you can see them below the video, like running by slowly. These are all sponsors that have they've either given us like cold cash, but mostly our sponsors have given us like components or like valves, or given us huge discounts on the product that we need to build the rocket, because it's not simple components we use in the rocket. They need to be able to withstand a certain kind of pressure and a certain kind of wear and tear, I guess you could call it in general. So, but of course, we've also had to fundraise a lot in DanSTAR. We're part of the DTU Blue Dot projects, which is a portfolio of projects at the Technical University of Denmark. We're presenting today. And it's a portfolio of projects that are kind of meant to do something extracurricular. So it's outside of our normal like school schedule, or we don't have classes per se. So it's project based on the engagement of and curiosity of students within different fields. I think most people have heard about the eco car from DTU by now. I think it's 10 or 11 years old by now, the project. And that is the car that can run like 700 kilometers on 1 liter of fuel. So we're in the same category of projects as that eco car, which means we get some funding from DTU as well, of course, which is essential for a project this size. Size-wise, the rocket is actually 4.5 meters long, so it's pretty tall. You'll be able to see it later. If you haven't already seen the pictures of it that we shared a picture a few days ago with Sarah for scale. Hey Sarah. Sarah is not our tallest member of DanSTAR, but you can still see there's a huge difference in the. Okay. And you can still see it. It's a pretty big rocket. It's pretty slim, but yeah, it's sizable. I'm being told that we're preparing for another guest in the studio.
I see that you får morsan. Ta-ta! Hvad siger man så? Tak. Thank you.
But anyways, I mean, we're gonna keep talking, but if you have any questions or any comments, feel free to let us know either in the comment section or in the chat section of this live stream. It would be a lot more fun for us as well if it's a two-way conversation. If you have anything you'd like to ask us or any curiosities you have about a rocket project, which in itself sounds great, you know. So if there's anything you've been wondering, like, I guess I told you a little bit about how we fund it, but if you have any questions in regards to the structure of the team or whatever, feel free to let us know. While we wait for the next guest, I can tell you he's from the electronics team. So like I mentioned, Peter, who was just here, was part of the mechanical team, and I myself am a part of the marketing team. So we have different teams responsible for different types of work in DanSTAR. So we have a marketing team, which is of course very small because it's not the main part of the project, but nonetheless it's important to manage public relations and make Facebook posts and get the word out about what we do in DanSTAR. We have an electronics team, which is the hardware electronics, I guess you could call it. So like actually like designing and making PCBs and and then we have a software team. Actually, we have the current software lead from the software team here, so maybe he can join us for a few minutes.
Yep.
Hi.
Hi.
This is Nikolai.
Hi.
Do you want to tell us a little bit what you do in the software team?
So basically, I keep track of everything going on, from the mechanics, the electronics, to the software. So I try to put everything together so it plays well, or plays nicely. So yeah, it's a lot of keeping track of everything's going on from every single team in order to make a fully functional rocket. Because you need to understand how the mechanical parts work in order to actually have the rocket running properly, but you also need to understand the electronics as well. Yeah. So yeah, it would be nice if we have the staff with us. We have Adam is currently getting that, so we can showcase what we're actually playing with when inside the rocket. Yeah, but it's all written in C++, if that makes sense for a technical perspective.
So if you're good at C++, we actually have an open position as the next team lead in software. If you're if you're interested, yeah. So
Yes.
in 3 weeks when we're done with Portugal, hit us up if you're good at C++.
Yeah. So basically, so basically we started on the software almost 2 years ago. Back when I joined, it was just starting up on the software department. That's when we had our first board built and starting developing the actuations of the valve from scratch. So everything is basically made from scratch when it comes to electronics and software by our own students. Currently we have like 12 people working on the software, and I think we have like 10 electronic students from all different departments developing in-house boards. So we have a lot of PCB designs, and yeah, everything is custom made by ourselves.
Yeah, so that's also a part of the competition we were supposed to participate in. Basically, there are two different types. You can do it with components off the shelf. You can buy everything you need to build a rocket, or you can design and build everything yourself, which is what we did. So it's a little more work than just buying it.
Yeah, it's been a really long process, and we have destroyed the electronics many times
so
before
many times.
and hotfix stuff in the last minute. But currently everything is working, fully functioning, and there aren't any software issues and no electronics issue. The only issue we have right now is the check valve.
Yeah, that's the valve that Peter explained before. That it's a one-way valve.
Yeah.
Yeah.
Yeah, I can, to give a short update on that, there was some dirt that got into it from the bottles, so they are installing a filter on the hose in order to prevent that from happening again. But yeah, they are almost done with that, and then we can start filling up the oxidizer, and then we have to top up the nitrogen tank as well for pressuring the system.
So is there an ETA on how much time that will take?
It's hard to tell.
That's the eternal answer here
It's
in DanSTAR.
it's DanSTAR time.
DanSTAR time. Yeah. It's you never know if it's maybe if you're lucky it's 10 minutes. If you're unlucky it's 4 hours. So, but that's in general. We don't think it will take 4 hours before we get to a test. Don't worry.
But in order to talk properly about the software, I think it makes sense to talk about the electronics first. And Adam is ready with all the electronics to show that off.
Nice.
So,
like I mentioned, Adam is the lead of the electronics team. Welcome, Adam.
Hello, people. So nice to meet you here.
Nice. You brought some
Toys.
show and tell toys here.
Yeah.
Can you explain to us what we're looking at?
Sure. As you might know, the rocket doesn't really go anywhere without a flight computer. So, of course, the mechanical stuff is extremely cool because you can see fire and hopefully not explosions, but gas sounds
Controlled
definitely.
explosions.
That's true.
Yeah.
So you can see all that, but the thing which makes that possible is actually sitting here in these boxes. So when DanSTAR decided that we will go ahead and try our luck with building a student rocket, we also decided that maybe also the electronics people should have some fun, not just the mechanical guys. So we started designing a flight computer from absolute scratch. Like a rocket doesn't really get more ambitious than that. So throughout, I think 2 years was it? Yeah. So right around 2 years it took us, but we basically built up a flight computer capable of measuring pressures on 8 channels, temperatures on 6, capable of controlling servos on 6 different channels. It has its own internal power regulations for the motors, for the logic circuits, for the measurement circuits, and it's all in one compact unit, basically handling everything from telemetry to the control of the engine. So if you want to, I can show off all the interesting things what I have here. But do we have any questions so far?
We don't have any questions so far. We have a shout out from Mikael. Thank you, Mikael, for saying go DanSTAR. we appreciate the support from everyone here. Yeah. So go ahead and show your toys.
Yeah. So everybody knows Arduino, I guess.
Not everybody.
Not everybody. Okay. So Arduino is basically a platform.
Oh, we have a question here actually.
Ooh, okay.
How many hertz do you measure data at?
Well, it depends on it. Thank you for the really interesting question actually. So it depends on the channel. I think this is a question for Nikolai, but he will answer that in the software section. So what's happening is that the different data inputs, so the pressures, the temperatures, the orientation and temperature of the electronics bay, the battery voltages, you name it. All these things come in through different hardware interfaces. Like we have different ADCs for analog to digital converters for all these different measurements. And besides the theoretically maximum, I think it's 100 kilohertz readout rate of those, it's really software and the capabilities of the internal CAN bus, which limits how much data we can push through these. I don't know the number, Nikolai should does. I'm just a humble electrician.
Do you know the number, Nikolai?
Depends on the measurement unit.
Depends on the
Depends
measurement
on the
unit.
measurement unit. But yeah, I think he will answer this question in more detail. But maybe let's go through some of the things here. So the idea was that this flight computer is developed by students, right? Students don't work on this full time. So everybody took 10 minutes here, an hour there, 3-4 hours in an evening or in an afternoon. And this way, usually if you just try to put something together with this bird structure, then it ends up being a patchwork of components and different design styles. So we decided to, instead of having it as a disadvantage, just stand into it and make it into a feature. So what we did in the beginning is we divided the system up into different sections. One board measures pressures, one board measures temperatures, one board handles the actuation, and then some other board handles the telemetry and the power distribution. So we designed a system which basically fits together like Lego. You have all the different functionalities, and then you give different people from the team responsibilities for these capabilities of the rocket. For example, I'm holding here a pressure measurement board. So this board does nothing else except takes the 5 volts and 15 volts, what is handed to it by the power distribution system, and then just measures the 4 to 20 milliamp signals which come back from the pressure transducers. And then you have the second board, which handles the temperature measurements, which just, again, takes the 5 volts coming from the power distribution units, puts it through the proper circuitry to the signals outputted by the thermocouples, and then saves it to its internal flash and pushes it into the internal data bus. And then these two units just pop together like that. And then you have another unit which handles the internal timings and communication with mission control, what you can also pop on top. Now you start to resemble a flight computer here. Then you have an actuation board which handles the servo movements and all this.
For those of you who don't know, we had some issues with the mechanical device inside the rocket.
Okay, something interesting is happening.
Did not come from us, came from the bottle. It's solved now by adding an inline filter which was produced in the last 45 minutes to the fueling hose. Everything's installed now, and we'll just pick up from where we left off, basically. So that means we'll be doing a repressurization. The rocket is already fueled with alcohol, but then we will redo the nitrous tanking as well. Because we opened a new nitrous bottle in the past fueling, we'll probably now have to replace the nitrous bottle once or twice during the fueling because we have a few nitrous bottles filled with something. So we expect a longer nitrous tanking, but on the other hand, we will be going all the way up to at least attempting a full flight duration burn.
Amazing.
Nice. I don't know how much of that you guys heard. Can you let us know in the comment section if you actually heard what Rasmus just said? Rasmus is our current chairman and lead of the mechanical team. So he's the guy who knows, what's happening with the. Okay, you can hear. Okay, super. So yeah, hopefully soon the actual burn will happen. Oh, someone couldn't hear actually.
Okay. So a quick recap. The mechanical guys managed to clean out that one-way valve, what was mentioned before to be the culprit of basically spoiling our attempts to light up the rocket in the morning. So it has been cleaned now, thanks to the work of several people, I guess, in the past hour. So now we will retank the oxidizer. The fuel, the isopropyl alcohol, is still in the rocket, and we will have to redo the high pressure pressurization at least to some extent. And after that, we can fire it up. We need to expect a longer fuel time for the oxidizer because we have to basically scrape the bottom of some bottles that we have. But besides that, it's so fine. So it seems to be we are back on track.
Yeah, and we'll be doing a burn that is going to be the same amount of time as the one when we're actually launching. So normally when we test, we do pretty short burns just to see that it actually works. Because it obviously takes a lot of fuel, a lot of oxidizer to do these burns. What is it, like 600 kroner per minute or per second?
Per second.
Per 600 kroner per second. So it's pretty costly. So we don't do these full duration burns very often, but we'll treat you guys to it hopefully very soon. There's one quick question. Are that relays? I don't know what that means.
Relays?
Yeah.
Well, which one? Did you see it on one of the boards or?
To the person who asked about the relays, did you see it on one of the boards?
We do not, like, just to clarify, it is a very, very, very bad idea to put electromechanical devices on something which will be in a high vibrational environment like a rocket. So we do not do that.
Yeah.
We do have some relays on
Blue blocks.
blue blocks.
Yeah.
Oh, these things. No, this is part of the test system. So this board is actually not a flight model. This is for us to debug our system while it's on the. I do. Aww.
So you can come back.
Okay, fair. Yes. Yeah, I will go and install the igniter. But you know what? I will leave the toys here and I will pass it over to my good friend Nikolai. I think he can tell you a lot of interesting things about the software. So have fun. I will be back.
Thank you, Adam. There's also a question here. Maybe you can answer that, Nikolai. I'll come back. Someone asked if this electronics design will be used in future rockets, or do we plan to start over?
So the current plan is that we are going to reuse it, as far as I know. It should be reusable. And the next plan is currently we are talking about doing active guidance on our next iteration, but we're not 100% sure if that will be a thing. So we'll figure out how to implement that in the current electronics solution, if that is what we're going for. But there's nothing officially yet.
But so, like Peter mentioned earlier, with the parachute, we do intend to get everything down in one piece. In you know, it's not a use once and throw away. It's not a single-use rocket. Oh, thank you, Steven, for yeah, go Nikolai.
Yeah.
We appreciate you, Nikolai.
Yeah. So there was a
Thank
question.
you, Mikhail, for the luck.
Yeah. So there was a question about how often we do measurements. So to give an answer on that, it really depends on the board and what kind of measurement it is. So what we do is everything is run off of timers, so we can decide how often we want the measurements. So it depends on the mechanical team, how often they want it. Yeah, that's how we currently do it. So to describe a bit more about the software, so each of the boards have their own microcontroller, and
What is a microcontroller?
it's basically a small CPU that has different functionalities. So they have functionality to communicate with the different components on the board. So we can get the data that Adam talked about, the analog to digital converters, and yeah, every single component that goes on the board. You need a special communication protocol, and this microcontroller handles that, and that's how we're doing stuff. So to go more into details about the boards, what we wanted to do with the software is to design it so in case one of the boards fail, another board can take over the control of the rockets. So you have basically a priority list throughout the board stack together. So in case the current leader in the stack fails, then the next board will take over the control of the rockets. So, and in worst case that the communication breaks down throughout the entire stack, then each board can run on their own and do whatever it is supposed to do during flight, and hopefully we'll get the rocket down in one piece, even if we have a single failure in the communication between the boards. Then everything, so when the rocket is on the ground, we communicate with it through a cable. We have a 1 kilometer cable that we are able to transfer data through. To give an idea about data rates on that, we are transmitting data with 1 megabit data, so it's not the fastest, but it's good enough for what we're doing, and it's quite impressive that we're able to do that over 1 kilometer of cable with minimal errors throughout that. So I can talk more about the software, but it's going to be really technical. And
are there anyone watching who has a background in software? Oh, what language?
Everything is in C++, and we are doing very modern programming. Normally, when you are you used to do it in program languages like C, but we're actually doing in C++, and we're doing in the newest version of C++, and everything is designed so you don't need to understand embedded programming to sit down and program it. Basically, I have no background in embedded programming. This is not even my area. This is just a spare time hobby.
Yeah. That's actually the case for most of us here. As you may know, we don't really have a formal education in Denmark within rocket building or that type of engineering. I don't study marketing either. I'm a chemical engineer from DTU, so we're all like venturing a little bit out of our field of studies. Yeah. But that's the beauty of it. You get to learn something that you wouldn't learn in the auditorium. So if anyone out there who's very new in their studies and would like to learn more about rockets, come join us after Portugal. We'll be looking for new members, and we'll do a recruitment run as we did last year as well. Are you running bare metal or with a RTOS?
So we are not running RTOS. So what we are using is a framework called ModM. It's a really lightweight framework that is bare minimum, and it's drivers are written from scratch to each of the different kind of processors.
There's also a question, sorry,
Yeah.
will the G-forces from actual launch make for different burn flow characteristics than in static testing?
This is not a question for me, at least. I think we need one of the mechanical guys to answer that.
Can we get a mechanical guy over here?
Peter?
Can we come back? There's a question that you may be able to answer for us.
You can take this.
Welcome back. Will the G-forces from actual launch make for different burn flow characteristics than in static testing?
Yeah, that's a very good question.
I think so too. Thank you for the question, Michael.
So, when the rocket takes off, if I remember correctly, it will experience an acceleration of around 4 to 5 Gs. And whether that will change the flow characteristics, to be honest, we haven't done any calculations or tested anything related to that.
The flow characteristics.
To the flow characteristics. If anything, what it will do is that it will increase the flow of fuel and oxidizer through the lines, because they will experience a downwards force due to the picture's force due to the acceleration. So maybe a bit higher flows. But to answer the question, we're not sure.
It's a pretty precise answer. We're not sure. It's a relatively common feeling like, oh, we're not sure, but we'll find out one way or another. Just to explain a little bit, you see a lot of cars driving by us, like behind us, because we have wires all the way. This is like our mission control area is to this, your left, my right, and we have a bunch of wires from here to the rocket, and we can't have people driving over them, like running them over with their cars. So there's this little thing here that people can drive over instead. And as you can see, a bunch of traffic cones all the way down to prohibit people from destroying our stuff. Halfway to the rocket, I don't know if you can see it on the camera. There's a generator. Maybe you can hear the other one in the distance. We have two, which is what powers everything here today.
Powers everything. Powers the small pumps that we use for the fire extinguishing system, and also powers a big pump that we use for a big fire extinguishing system, and powers mission control and the electronics on the rocket. Actually, the electronics on the rocket are powered by their own battery.
But we have our own power supply, so we don't take anyone's power or anything. There was a power shortage at DanSTAR yesterday, and some people came by and were mad at us because they thought we did it. We did not. We didn't have anything to do with that. We have our own power. Don't worry. Yeah, I don't know how far they are from being ready, but feel free to shoot us with other questions if you have them, technical or not technical. I probably can't answer any of the technical ones, as I'm not a part of the technical team. But if you have questions regarding how to make a Facebook post, that's kind of my expertise in DanSTAR. So otherwise, I will get an expert from whatever field is necessary.
Pull in the different designers.
We are 20 plus people here today. So we have all the experts with us. Adam is back. Do you want to continue your explanation of the boards?
Well, I wouldn't want to interrupt Peter in.
Well, I have already answered the. I said
okay.
that
so
there was a question.
Adam had to leave because he had to install an igniter, and the igniter is basically what switches on the rocket itself.
The boomstick.
Huh?
The boomstick.
The boomstick. Yeah. Do we have an extra igniter somewhere that we can show?
No.
No? Okay. Maybe later we'll show you. Oh. Do you guys, girls, thank you for being inclusive, have a time frame when you're ready to launch? I need to do some things, but I want to see it happen.
Yeah.
Nikolai will go ask.
Yeah.
We wouldn't want you to miss the big thing. It's pretty spectacular.
Do you think it will be possible that we will get a 5-minute warning anyhow when the fueling team comes back? So maybe we can shout out on the social media platforms just to like
That's true.
fire in 5 minutes.
I don't know if it's if 5 minutes is enough for you, Nils, but we will do a 5-minute shout out, or at the 5-minute mark we'll be like, it's happening, guys. Get ready. But we sent Nikolai to ask, is there an answer on the
There's
time frame?
no exact time estimate, but they're currently starting filling the oxidizer tanks again.
Okay.
Yeah. So it depends if they run into issues.
Yeah, usually I can tell from the experiences from yesterday that usually when you're on the fueling crew you spend 20, 30-ish minutes on the pad talking on the phone with mission control. You have a very long checklist with bullet points for everything. Then you just go valve open, nitrous is fueling in, or I don't know, valve disconnected. So you have a really, really long checklist, and every single point is meticulously followed. So what is taking this long now is to actually get the nitrous from the bottles, what we get them delivered into the rocket. We have to wait a longer time for that because we have a lot of restrictions in the line, and also the rocket body is quite warm now, so it needs to cool back down to temperature.
And of course, safety first. So we don't ever do anything without having confirmed that it's safe. That's also something you'll experience when the actual launch is coming closer. We will leave you guys here because we will all have our duties. We have scout teams, which basically means you get a really nice fluorescent yellow
Safety
vest.
Yeah, so people take you
beautiful
seriously
vest.
when you say
Can we get
that.
a scout over here so they can see?
Here is our example scout.
This
Victor.
is an example of a scout. So we deploy model scout here. So we deploy these scouts basically all around the area here to make sure that no cars, no pedestrians, no bike people, no one
Accidentally wanders into the area where it might be frightening.
Yeah, we've had some people like driving right up next to the rocket these past few test days. We've had to explain to them really calmly and nicely that we're about to switch on a rocket here, so please park your car somewhere else if you want it intact.
But interestingly enough, if you have a safety vest on, people in cars take you seriously.
Yeah,
So.
luckily. Yeah, this is actually one of the nicer safety vests we have. We have other vests that are like kind of like crop tops.
It's a fashion statement.
It's a fashion statement, that's what we tell ourselves at least. Yeah. Thank you for modeling for us. Yeah, so when the actual launch will start, or when we get closer, we will just put the camera so you can see what's going on, and you'll be able to hear the countdown from mission control, and you'll be able to see that everyone has their duties to follow. Yeah.
But where did we leave off? I think we had a question about the blue things on one of the boards.
Yeah.
And I was just about to explain that we.
Someone asked when will I be able to go on the rocket to go to the space?
Well.
A few years, give or take.
Not to space, but you know, it goes to 10 kilometers and it has some extra lift capacity. So.
But I guess this person would like a seat. We'll save you a seat on the next one. Actually, maybe on the second rocket, because we promised Andreas Mogensen, the Danish astronaut, that we would save him a seat on the first rocket we built that is manned.
But actually, if you want to hear more about manned rockets, be sure to check out Copenhagen Suborbitals. They are right next door, actually. They have.
Yeah, I mentioned them in the beginning that I had a conversation with Peter about them being our brother/big brother, because it's a bit larger scale rockets that they do, and their mission is actually to send someone into space. We're not exactly close to space yet, but one point that is actually important to mention is the fuel, because there are basically 3 different types of the fuel types. So we have a solid type of fuel, which is like a New Year's rocket. You light it on, it goes somewhere. Yeah. Then you have a hybrid, which is some solid and some liquid. And then you have a bi-liquid, which is what we have, which is of course 2 liquids. And if you want to go to space or Mars or wherever SpaceX is going, you actually do need the bi-liquid type of fuel. Which types of liquids you use, that can vary, of course, but it is the type of technology that you want to use.
Mostly for controllability. Like there is this very nasty habit of solid rockets that once you light them off, they really can be turned off. And actually the American space program has a pretty terrible track record with them.
Oh.
I think two space shuttle failures out of
Yeah.
2 are attributed to the solid booster. So
Yeah.
they have their uses, but we are doing by liquids.
Yeah. Someone said that we should try out with an animal first before a person.
Well,
I think we should stop sacrificing dogs in space. For my whole life, most of my life, I believed my parents when they told me that the dog came back to
no,
Earth.
it did come back.
Yeah, well, alive.
That's a
And it's
different
only
question.
within the past, I'm a little bit embarrassed about this, but it's only within the past 3 years that I actually learned that the dog did make it. And that, not gonna lie, it made me sad.
Well, we do have a 3-unit CubeSat space,
Yeah.
which we don't really have a payload for, so we will fly with something called a boilerplate payload. So it's basically just a weighed out volume. What we will put in the rocket. So I have heard several ideas what to put inside, and one idea was that everybody from the team should give small personal objects, and then we could fly them. But the way the big boys do it is usually with a concrete block, and then we have some creative types like SpaceX who actually put a car on top.
Car, yeah.
And,
We considered getting a Lego car to put in our rocket just for the fun of it. I'm not afraid of starting a third world war by accident with this rocket. No, we're not. We're not afraid of starting a world war with this rocket. I don't know why we would be afraid of that.
will there be a small camera on the rocket while it flies? Of course, great question.
Yeah.
Actually, it leads us right back to the electronics. So actually, we will have 3 small cameras on the rocket. While it flies, one will look up into the parachute bay. So if, or not if, but when the rocket comes back to us, we can actually check whether or not the parachutes opened as they should or should have. Then we have one camera facing down into the engine plume actually, so we can see the ground getting smaller and smaller hopefully, and we can also catch some of the nice firing footage from the first 13 seconds. And then we have one camera looking out sideways from around the midsection of the rocket. These feeds unfortunately will not be streamed back from the rocket because we decided that it is a student project, so complexity needs to end somewhere. So we opted for cameras which are saving for an SD card. So when we recover the rocket, we will be able to review this footage, but unfortunately not before.
But hopefully afterwards we can post that footage everywhere so you guys can see. Niels, I'm not sure what you're asking why about, but if you can specify your question, we'd love to answer it. I don't speak Spanish, unfortunately. I think it's
But
Spanish.
we do have someone who does, actually.
I don't know where they are.
Steven. Yeah, Steven is not.
Steven was watching the chat earlier, so maybe he can translate. Maybe.
But okay, actually, if we don't have any more questions about electronics, then I will just look around and try to be useful.
Yeah. If there are any. Okay. Well, if you have any other questions about the electronics, now is the time. Just Adam will leave us for the time being, so maybe a few seconds if you have anything. Otherwise, you'll have to make do with me for the next couple. Oh, thank you, Christina. She expects everything to go well. Thank you so much. Will the rocket break the sound barrier?
Yes.
Yes, it will.
Yeah, I think the highest speed what we're expecting is 1.3 Mach.
So that'll be exciting.
Yeah, hopefully it will break the sound barrier in one piece.
Yeah, hopefully it will break the sound barrier, but not break itself.
Yes.
So fingers crossed.
Would you be okay if I left this here for
Did you ever have ground issues? Yes, leave the iPad.
Ground issues?
Yeah.
Oh no, the nightmare
What
starts.
an evil question.
Yeah, we do. Actually, we did. Like, yeah. So we use a really interesting power distribution scheme on the rocket. The idea is that all the different boards have a dedicated controller section, which is basically the microcontroller and all the support electronics what you need for it, oscillators, and buffer capacitors, whatever. That thing runs on a 5-volt supply. That 5-volt supply is then galvanically isolated from the rest of the circuitry. And also on a different, from that it follows that it will be on a different electrical ground level than the rest. So we have basically the 5 volt isolated, then we have a 5 volt power for powering everything which goes out from the flight computer. Then we have a 7.4 volt power line for the servo actuations. Then we have a 15 volt power line for the 4 to 20 milliampere sensors, and then we have a 12 volt power line for all the cameras. All these things, all the power lines run on a power ground. The logic side is running on a logic ground. These are also supplied from 2 different sets of batteries. So we try to do our best to actually keep the different power planes as separated as possible. It actually saved our asses several times over when we were not on top of our game and we connected the wrong wires to the wrong places. Because this way you can catch the surge with the galvanic isolation, and you don't have to rebuild the entire computer, only half of it. So that is something. Also, it's quite reassuring to know that even if you have an electronics failure, on the power side your logic will keep shooting, and you will be able to get back as much of the uncorrupted data as humanly possible. So yes, because of this system, we also have to use 2 different ground levels on the launch control box, which does the charging and the signaling for the rocket that it can actually go. Because one of the very interesting problems is that thing, according to the Spaceport America Cup rules, needed to be at a maximum 1.4 kilometers away. How the hell do you push some signal through 1.4 kilometers of wire? So that's also an interesting grounding issue. Then you have to provide electricity on the site and on mission control as well. So yes, we had grounding issues. They are a nightmare to debug.
Yeah.
So
but we solved them.
Yeah.
So thank you for the question.
What do you use for telemetry? This is a question for
Oh, that's actually a good question. So telemetry is actually the final team that I didn't get to mention before.
Yes. Should I go and try to find Fabi
yes,
for
please.
you?
That would be great.
Yes. Okay. Guys, I will leave this here for eye candy.
Thank you. Thank you for your time.
Of course.
Yeah.
There are more information on the website.
Yeah.
If you are interested.
A lot more information. But as I mentioned, telemetry is the last team. We actually have the team leader of telemetry here. Telemetry, for those of you that don't know, is basically how we talk to the rocket.
Yes.
Fadi, do you have time?
Yeah.
Okay.
Because someone asked what we use for telemetry. Thank you, Adam.
So what specifically does it mean?
What do you use for telemetry?
Like what chips or?
What do you mean by your question? In the meantime, Nils asked if we have any pictures of the rocket. If you check out our Facebook page, and the Instagram, we recently posted some pictures of the rocket as it looks right now. I don't think we have any pictures of it with the nose cone on, like right now, like very recent pictures. But you can see what it looks like right now, hanging in the concrete bay down there on our Facebook page. But if you can close crop.
I have a question for the telemetry.
Chips frequency protocol antenna.
Can I ask a question?
Yeah.
Fadi, if you had to explain to like a non-engineer how does the telemetry system work? What components?
To a non-engineer.
Non-engineer.
What components
So
are there and stuff?
So basically there's a radio chip on it that you can use to transmit data, Wi-Fi, just like a Wi-Fi system. And that chip has an amplifier to amplify the signal, so we can transmit all the way down to around 9 kilometers. And then we have antennas on the ground pointing at the rocket, so while the rocket is flying, I will be standing outside and just pointing the antennas on the rocket. And trying to make sure that we get all the data down. So basically the telemetry system is there as a backup system. So the rocket has parachutes, and it also has flash. These flash are where we store the data. If the parachute system works, and the flash system works, and the rocket gets down safely, we can extract all the data from the flash. If the flash doesn't work, or if the parachute doesn't work, there's a chance that the rocket will just fly down and crash, and the flash will destroy. And if that happens, we will not have any data. So the point with the telemetry is basically as a backup system, so that once the rocket is flying, let's say the parachute doesn't deploy, it will start flying really fast down, and I can still point at the rocket and get all the data all the way down to when it crashes. and that way we can figure out, maybe we can figure out what happened, so that we don't repeat the same mistakes on on the new rocket we build, maybe a year from now or two.
When we,
Yeah.
how advanced next will be. Did that answer your question? Otherwise, you can follow it up with more questions, I guess.
Yeah.
There's a question about it says chip frequency protocol antenna.
So frequency 2.4 gigahertz. What was it?
Protocol antenna and chips.
So protocol modulation is TFSK. Protocol, I would say a protocol we made ourselves. Depending on like how deep you go down. If you go very far down, there's on the tip a specific engine for that. And they're like, do you know if we actually use that engine on the term engine? I don't think we use that engine.
We're using the standard NRF protocol.
Yeah, so it's a standard NRF protocol from Nordic Semiconductors, I think. What was the antenna? So on the rocket we have 3 patch antennas, very small ones, like no bigger than this, 2 times 2 centimeters, with a home-built backplate, and they are placed 120 degrees separated, and one of them pointing slightly down, one of them pointing slightly up, one of them pointing straight. And the idea here is that we expect the rocket to spin, so in that way we will get data throughout the whole flight. Or we are assuming we get data throughout the whole flight. On the ground we will have helical antennas, 3 of them pointing on the rocket, and then we also have a cross-Yagi antenna that I built for the commercial off-the-shelf flight controller, which also has its own dedicated telemetry system, running at 433 megahertz. That's the frequency, I think. So actually we have 2 separate systems that we use to double take the data. Home built and one we bought also.
So it's you can kind of like, if you press start on Fadi regarding this topic, you can get him to talk for
That's
a lot of hours.
Yeah.
If you're really interested in this. But yeah, feel free to ask any questions about it. Is there any more for the?
So it's actually not over 7 kilometers. So 9 kilometers actually, 2.4 gigahertz, 9 kilometers.
Yeah.
The total amplifying power is around 22, 23 dB, and then the gain on the antennas is around 16, 18 dBi. That should get us around 9 kilometers. Hopefully.
Yeah. Well, hopefully the fuel will get us to the 9 kilometers as well. Yeah.
We did already we did do some tests outside, and we got it up to 3.5 kilometers, but at that point it got too dark and too windy, and I had to pack down and go home. But I haven't done new tests since then, so I expect it to work at least at 5-6 kilometers, and hopefully all the way up to 9.
Yeah. And hopefully the rest will get up to 9 as well.
Yeah.
Because of course you don't bring extra fuel, you don't bring excess. We don't bring fuel as if we were going to 20 kilometers. We bring basically what we need.
Yeah, exactly. Else it will just be dead weight.
Yeah. And we had to make some adjustments to the engine. In the beginning it was 3D printed aluminum, but we realized that it would melt, right?
Yeah. So Rasmus, he's basically.
Rasmus is the mechanical team lead, as I mentioned earlier, the guy who was explaining what was going on.
Yeah. He wrote a special about the rocket engine, how to design it, and the first iteration, he had like an idea how it should be done, and then we 3D printed it, and then later he did some more CFD calculation, and he was like, yeah, probably it should be or should be stainless steel to be absolutely sure. So it's a type of stainless steel we're using for the chamber, and then aluminium for the injector and oxdome. Yeah. Any more questions?
Any more questions? Yeah. Currently, no questions. Yeah, I don't know. Do we have a time estimate now?
So they need to change to a third bottle now. They have about 7 liters on it. in the tank, so it needs to get to 16 liters. So it's halfway there. They just need to do the last change.
Okay.
So that sounds like 20 minutes or something like that, because they have to replace, put the bottle in. Yeah.
There's already
So about 20 minutes from now, hopefully, we'll be just about ready. So if you got stuff you need to do, I think it was Nils who said that he had some other plans that he needed to do as well. You can leave us in the background and check back in 20 minutes if you need to do so.
So they filled the tanks and now they're waiting for it to boil off.
Okay, so that's less than 20 minutes.
So they actually fill it full?
It's filled, now they're waiting for it to boil off and then they are going to fill it up again.
Ah, okay, so probably the top of the tank is still too warm, so it makes the nitrogen oxide boil.
So can you explain what that means to?
I'm not exactly sure, but I assume it's because the it's a common bulkhead tank, a really long one. So probably at the top it's too warm for the nitrogen oxide to stay in liquid phase. So it will start boiling off, and once it boils off, it will cool down the tank with it. Of course, you will lose some nitrogen oxide, and then at some point, the whole tank should be cold enough for us to put more nitrogen oxide. Yeah, so they have to replace the bottle and get a new bottle and fill it up again. The rocket.
Yeah.
I thought he was here.
But again, with the time estimates in DanSTAR, it's always a little tricky.
You never know what can happen, so
Yeah.
So
You can actually see people that are participating. No, it's only us.
yeah. Do you have any more questions? Just ask
Doesn't seem like it.
on YouTube chat channel, live chat. There's like a live chat on the right for some of you maybe on the phone. Maybe you should be able to search find it. Ask anything. Like doesn't need to be telemetry.
It doesn't need to be technical either. It
Yeah,
can be about
technical.
the logistics of getting 25 people to the US
Yeah.
or to Portugal. And how do we transport a rocket across country borders and the likes? If you're interested in hearing any of that, we can also show you a bit more of the area if you're interested in. Because right now we're only showing you the part that's pointing towards the rocket. What are some of the funniest moments that happened while working on the rocket? Funniest moments. I mean, every day is fun when you build a rocket, of course.
I think it's really hard to answer that question because when you work, you're working.
Yeah, I mean it's hard work for sure.
The fun comes in between, I would say.
Yeah.
That's for me. I mean,
So, to kind of explain how the workflow is in the team, first we're all volunteers, so we do this in our free time, but it's still, in at least our own impression, I guess we're biased, but in our impression we're one of the most dedicated, time-wise, volunteer students at our university. Because you don't just build a rocket overnight, especially not a rocket of the complexity that we are building with the bi-liquid engine, as I mentioned before, 3 different types.
And without having the proper background knowledge.
Yeah, without having a formal education in how to build a rocket, because no one does in our country. So we spent a lot of long days, long weekends, long nights, long test days as this one. We met up at 8:30, both yesterday and today. No matter if it's raining or windy or whatever.
Oh, storming.
It was literally storming yesterday. We made the most janky fix for our camera tripod yesterday to make it not wobbly for our recordings. So
I have an input for one of the funniest. For one of the funniest moments.
Peter has a funny moment.
I think it was also a desperate moment, but some of the times where we have been out on a test day, we've set up.
That's what I was trying to explain. Yeah, the long test days.
Yeah, we've set up the pavilion tents.
Yeah.
Oh.
And then there's come a big wind gust.
That's true, yeah.
Yeah, that's
Big
loud.
gust of wind, and then the tents have started like lifting up,
And we
yeah,
haven't even started testing, and it's half broken. And
Yeah.
started blowing away, and then everybody has desperately been trying to hold them
Yeah,
down.
yeah.
That was
Yeah.
quite a comedic moment.
Even the supposedly good quality tents that we bought turn to butter when it's too windy. So that's been interesting to say the least. We had a hot fire test day, so an engine test last summer. It was in June even, so it wasn't even like winter or anything, but it was like a legit storm. We could hear the thunder and the lightnings coming closer and closer, and we had
The show must go on.
the show must go on. Yeah, we needed 4 consecutive successful burns that day to call it a success, and we had 3 consecutive successful burns, and we needed the final one. And it was pouring down. We had people holding down the monitors and the laptops in the mission control area. We had we had people holding like each leg of the tents because everything was just blowing away. We had just accepted that, okay, life is awful now, but we gotta get through this because we need that final 4th consecutive burn. I mean, we got it, and then we packed the shit up and went home.
And the funny thing about that is that the 4 consecutive test we did, it was just an arbitrary number. Like we just put a 4 as the number. It could have been 3 or 2, but we just.
It was a matter of principle by that time.
Just,
We needed
yeah, exactly.
the 4. So but when you're all in it together and it's all awful and raining and cold, that's also a bonding experience, I guess. Oh, greetings from Spain. Shout out to my brother Steven. Where's Steven? Steven, there's a shout out to you.
He wants to come over and talk as well.
Oh,
Do you want
everything
to
goes
talk,
well.
Steven?
Thank you so much.
Come, Steven.
Mikey. Luis.
Luis.
Yeah, one of your friends, I'm assuming. So this is Steven.
Hi.
Hi Steven, can you introduce yourself, what you do in DanSTAR?
Yeah, actually I'm part of the software team. Before our team leader Nikolai was talking about what kind of languages we use and so on. So yeah, I have been almost a little bit more than a year in DanSTAR. So I started from scratch.
Yeah.
And now I know how the software structure works. And yeah, it has been a really good experience for me and for my curriculum.
But Steven also actually helps me a lot in marketing.
That's true.
Because, of course, in marketing we also make sure that we document everything, take pictures, record videos, all this stuff to use for like PR and also just to use internally. And Steven is a great photographer.
Thank you.
And has helped me a lot because it would be impossible with just one camera and one set of hands to capture everything.
It's always better to have different shots of the same, different angles of the same picture.
Yeah. And, we have another photographer in the team as well.
Yeah.
Who doesn't want to be a part of the live stream?
I don't think I'm the right person.
You want to come say hi anyway? Just wave to the camera. Because again, it's impossible to capture everything with just.
Hi, Mom.
This is Balint, who is also helping out with the. The marketing team is a fluid team sometimes. We do what must be done to capture the right moments. Yeah.
But we always
we're
have.
not gonna lunch. Thank you, Stefanovic. We gotta say hi to August. Hi.
You
Can
want
you
to
wave
talk?
to your friend?
It's your turn, August.
No, we can talk about the nationality.
Stefanovic says hi. Yeah? Do you want to introduce yourself to our live stream friends here?
Yeah, my name's August, and I'm in the software team as well.
But you're not from Denmark, are you?
No, I'm
No?
from Iceland.
Yeah? So I don't know if you just heard Nikolai make a comment about the nationalities in the team. We have a lot of Icelandic people in DanSTAR actually, so if anyone's watching from Iceland right now, send more people because we need more members in DanSTAR. Mikael says, is Red Bull paying for the good exposure? If not, they should. It's very much on purpose that we put the Red Bulls here on the table actually, but they're not paying us for it. It would be nice though, so if anyone's watching from Red Bull, Call me. No, but Red Bull's actually sponsored all our Red Bulls. We get a few cans once in a while. So thank you to Red Bull for that. We joke that the fuel for the rocket is isopropyl alcohol and nitrous oxide, and the DanSTAR member fuel is the yellow Red Bulls. Please send more of those, the tropical ones. Yeah. But they should pay for the exposure for all of our 15 live streaming people. It's good exposure for Red Bull. 15 people. I actually don't know how many people are watching. Can we tell us somewhere?
50.
50. Oh, okay, that's a lot more than 15. Well, I guess one of them is like ourselves, or maybe like 10. So maybe 40, and then maybe some of them clicked by accident. I think like 10 people has been active in the chat, so thank you to those 10 people for chilling with us.
Now the nitrous oxide tank.
Okay, I don't know if you heard that, but Peter just mentioned that the nitrous oxide tanking is complete. So another step to cross off on the way to the ignition and the actual test, the burn. So hopefully soon. You can come back on, yeah. Wanna hang out with us some more?
Yeah.
Who's
the most valuable member on the team?
We have a lot of valuable members
Yeah.
on the team, of course.
I wouldn't say there is one that is the most.
It's not a one-man project.
Because you cannot do this as a one-person job. Like you need so many different disciplines in engineering. So, and you require a lot of people.
Yeah.
It's impossible to do for a single person the scale we're doing it right now.
Especially on these test days. We're 20 people.
Yeah.
We've been around 20 people all the test days here.
If we get everyone on camera to showcase how many are actually standing behind the scenes.
Yeah.
I think we are probably 25 members present right now.
Yeah. Which is also necessary. Of course, not everyone is active all the time. Like we didn't do live streams the other day, so but we've all had critical tasks during the days.
Yeah.
Yeah.
But what makes this team really special is that we have such a diverse background. Like we have everyone that just started their bachelor's, all the way to people finishing their master degrees, and we have so many different nationalities on the team.
So we take off most of the politically correct boxes for a diverse team. Not that has ever been a mission of ours, but it just happened organically.
But
We've got some families here today as well. I guess people are excited to see the burn live, like live in person. Does the rocket have a name? It does. Yeah, it's called Dragonfly. Yeah. So.
And we named it before NASA did it themselves.
Yeah, we've heard that NASA has a project called Dragonfly now, but we had the name first. So I think NASA should actually pay up for, taking our name. I don't know if you can see it on the back of my laptop here, but there is a mission patch for the project. I don't know if it shows on the. I don't know if you can see it, but it says project like Dragonfly project here, which is like any space kind of or rocketry related project with respect for itself has a mission patch, so we needed one, of course, as well.
So we're getting questioned when we do vertical landing, like the Falcon 9. So give us a few more rockets.
A few more rockets, yeah.
A few more years.
This one, if it lands vertically, that's pure luck. It's not we don't have that kind of control over it. I don't know if you were here earlier, Lawrence, but we have a parachute in the nose cone of the rocket, so it will fall down hopefully neatly and not be injured on the way. But it will probably land like horizontally. Thanks for the luck. What about acronyms? We have a lot of those, like NASA. Do we have a lot of acronyms? We have a few,
Yeah.
but I don't know if any of them are. I don't think we can say them here. They're not family friendly.
We have the electronic system is called Richard.
Yeah.
And I can't remember what that stands for exactly. Yeah.
Does anyone remember what Richard stands for? Adam? Do you remember what Richard stands for? The acronym?
Come again?
Richard.
What Richard stands for?
Richard, robust internal high altitude
Robert internal
controller for
something.
Something.
Yeah.
It has a really nice story why we actually named it Richard, but also for that it is private.
Yeah, that's what I'm saying. It's not really family friendly. Yeah. So we don't have a lot of the acronyms. But, so that means what? 5-10 minutes. So what will we do with the rocket after the flight? Hang it from the ceiling of Skylight. Maybe if Skylight will let us, or we'll sell it to a highest bidder.
Maybe we'll be able to reuse it.
Maybe we'll reuse it, yeah.
Yeah, that's the goal, at least, being able to reuse it for later missions.
I don't know if you heard, but scouts are being deployed now, which means it's only 5 to 10 minutes from the actual burn. So I'm gonna go set up my camera so I can record the whole thing.
We can move the camera to the mission control area so you can hear what they are talking about.
We'll move this camera. So stay tuned. It's gonna happen very soon. Balance, will you help us to move the camera to mission control?
Yep.
And we'll check back in with you later.
Over here.
Yeah. Sorry, can you give me some space? Thanks. This?
Skal jeg lade være? Okay, lad være.
Hej.
5 minutes for.
Tak skal du have.
Okay, so you can just hear the area here in front of mission control, so mission control can see what's going on. That's perfect. really close. Or okay.
Hvad siger du? Står de et sted, de ikke må stå, Gustav? Står de inde på vores område? Så er det okay. Ja. Det må gerne stå sammen med dig. Det er det, du siger. Ja. Okay. I lukker området af. Så er der afsnit. Klar til afsnit. 10.000, 1.000, 31, 5.000. Ja. 780, 36, 31, 00. 340, 49, 1200, 1200, 503, 100, 175, 500, 0, 500, 20.000, 4, 500, 0, 0, 500, 0, 0. Så er der logging. Logging er startet. Electronics go! Go! Pad go! Pad go! Nada go! Go! Gustav go! Lasse go! Victor go! Lasse go! Sara go! Sara go! Sara go! Just go! Yeah. Safety go! Go! All go! Internal power. Pressurization. Pressurization complete. T-minus 16. 8, 9, 6, ignition, 4, 3, 2, 1. Logging stop. Nej, jeg tror, der er ikke noget. Fuel dump. Ja, vi er ikke færdige nu. Stefan han laver lige 4. Vi er færdige nu. Nice work. Scouts, you can come back. Pad clear. Stay still. You kommer ned og kigger. Fik I data? Ja. Super. If you want to do a visual inspection of the pad, now would be the time.
Det ved jeg
Alright, welcome back to the stream. I hope you all enjoyed this burn. Because we're testing what exactly we're pointing at right now. I'm just gonna see if you have any questions while we were away. Thank you for the wishes of luck. Oh, all the way from the US. Thank you. Your system is so punk. It is pretty punk, yeah. The concrete blocks are someone tagged them. Basically. Yeah, we didn't. Gorgeous diamonds and thrust, right? Gorgeous. Yeah. Diamonds of success. Look great. It did look great, yeah, for sure. Concrete block gets worn, yeah. As you can see, you can still see it on the live stream actually, on the video just above mine here, like the top right corner. You can see kind of the dent that the fire, like the burn actually made in the concrete. It was a plain concrete block when we started last weekend. It's not anymore. The river is full of wind, yeah. Actually, it was more like Kazakhstan and Florida. Will you post a video of this so that we can make sure? Of course, we will post videos of this later today. I'll see if I can get a hold of it and post it to our Facebook during the day, but otherwise we will post it tonight. So you can share it if you want to. Yeah. Tap the rocket gently. Yeah, we gotta tap it gently. It's not that sensitive, but still it's still warm. You still feel on the rock that it was very, very hot still. Very excited for this soon. Guys, we're still streaming, so if you gotta yell, do it somewhere else. Exactly. Nice. Little show and tell action here. I don't know if you can see on the video. Maybe we need someone to hold it closer to the actual camera. It's burned to crisp, basically, this cable here. This is one of the cameras that was right in front of the rocket. The camera's fine. The cameras can endure quite a lot, but the cable obviously couldn't. Hopefully you can tell that it's basically crispy. Yeah. Space future is bright. That's right. What is the next step? Do you mean today or in general? Because the next step today is another burn. So if you hang tight, we'll do another one. So as I mentioned earlier, these burns that we've been doing previously have only been like 6-second burns, whereas this one was 13-second burn, so the full flight burn. You could say that. So this one was a 13-second burn, which is the duration of the burn during the flight, the actual flight in Portugal in a few weeks. So it's felt pretty good to everyone here. Safe to say. We were supposed to do one of these yesterday. We've only been doing the shorter burns up until now, but we had an error yesterday evening, making it impossible for us to do the long burn. Unfortunately, had a faulty igniter, or the connection between the igniter and the connection was not good. So the first long burn was today. What do we have here? Right now we're not sending anyone to Mars, but hopefully in the future, we will. Maybe not DanSTAR, but at least the members of the team. I think I speak for most of us when I say that most of us have an interest in working within rocketry-related industries. Unfortunately, we don't really have a rocket big rocket industry in Denmark yet, but we're working on it. Yeah, Copenhagen's Orbitals crowdfunding project that aims to lift up human into space. That's right. Maybe we can actually get one of the Concept guys onto the live stream here to talk more about what they do. That'd be fun. Don't see any of them right now, but maybe we'll get them back here later. We love this stuff too. Yeah. Thank you for the wishes of congratulations. The fuel for Dragonfly. The fuel is isopropyl alcohol, IPA, and a nitrous oxide, laughing gas. Like I mentioned earlier, the reason why we have the combination is because if you compare it to an engine in a car, where you get air in during the car ride, for a rocket in flight, you don't get air in during the flight. So all the oxygen that you need for your burn, you need to bring with you on the rocket. Yeah. And I think I mentioned that earlier. I don't know if you were here, Lawrence, for that, but we have 3 different types of fuel for this type of rocket. So you have the solid fuel, which is basically like a New Year's Eve rocket that you just light. You have a little fuse, you light it, and it just flies off. Then you have a hybrid, which is fuel, solid fuel, and liquid fuel mixed together. And then you have the bi-liquid, which is what we have. 2 liquids, which is the most complex kind. Because getting the 2 liquids to how to say it simply, to work together can be very complex. Yeah. If you have any questions regarding the fuel or the liquids, we have the fluidics team here as well, which is a sub-team of the mechanical team. I'm a chemical engineer myself, so you could answer any of your chemical questions if you have any. I guess that answered your question. You're welcome. So, in regards to the next part, there are some more preparations that we need to do, and that is going to take, I think, about an hour. Between half an hour and an hour.
Of refueling.
Yeah.
You guys are going in now?
Well, can we show it before you leave?
This is just the mechanical.
Okay. Yeah, but basically, this is the part of the igniter. So again, the switch that lights on the rocket. Thank you. Yeah, we use charcoal as well in the igniter because it burns really well. In there. I was AFK when you started talking, so I'm a few minutes behind the video. That's fair enough. Yeah. Won't spoil anything if you're behind the video. Do you have any questions regarding the test that we just did, or the burns in general, or for us in general? I'm sure we can hopefully answer most of your questions here. Kan du se, om der stadig er folk, der streamer?
Der er 32.
Material cost of the rocket? Well, that's a good question. So it's a pretty costly endeavor building a rocket, basically. Material cost. So a lot of the materials we didn't pay for in cash, or what you say, we've gotten a lot of discounts through a lot of our sponsors. I think they're still rolling underneath this video, the sponsors of the project in general. So we had a lot of sponsorships via, like I mentioned, discounts on components for the rocket. But I think we made a calculation, like a rough estimate, about half a year ago, where it was more than 1 million Danish kroner. So I think we're probably well above that by now. Of course, some of the costly things in building this is also, for example, renting out this space, paying a guy to stack the concrete blocks for the rocket bay down there. I mean, it all adds up. But the rocket itself, like just pure components for the rocket, probably about $1 million. Now, why did you choose this combo of fuel against other liquid fuels? It's a good question. Har vi Stig i nærheden? I can't answer this question on my own, but I will find someone who can. I've gotten this explanation before, but kan vi låne Rasmus et øjeblik? Nej, kan vi låne Stig her? Nej. Hvorfor valgte vi det her fuel frem for andre liquid fuels? Du svarer på det? Okay. Our friend Peter is coming back to answer the question.
So yeah,
why this combination of fuel against other liquid fuels, like methane and lux, etc.?
Yeah.
We've had this conversation about methane before, I remember.
Yeah.
Whether we should go into that.
So the reason we chose isopropyl is because it's relatively high performance, and then the overarching reason is that it's readily available. It's easy to get your hands on. Whereas other types of fuel like RP1, kerosene, which a lot of the big professional rockets use, that's very hard to get your hands on. And on the oxidizer side, we chose nitrous oxide again because it's available, and also because you can store it at non-cryogenic temperatures. So that means you can store it at relatively high temperatures relative to other oxidizers like lux. Lux, you have to store it at something like minus 200 degrees centigrade, whereas nitrous oxide you can store at around, we store it at around minus 40 degrees centigrade in the rocket. And that's a big plus, because if you have to store it at cryogenic temperatures, it puts a much larger demand and much stricter requirements on your components, which makes it a lot more expensive.
And complex as well.
Yes.
Again, it's a student project, so even though it's a complex project, we try to keep the complexity low.
Yes.
Where did the rocket motor itself come from? Was it built in-house or was it sourced? We designed it ourselves, actually, the rocket engine there. But it's 3D printed steel, actually. The Danish Technological Institute 3D printed this for us. It's the first of its kind in Denmark. We are very proud of that. So that's it's pretty sick. I'm pretty sure it's the first rocket engine that they've 3D printed.
Yeah. And it's absolutely essential that we used additive manufacturing to produce this motor, because it wouldn't be possible with any other methods of manufacture. You wouldn't be able to produce this kind of motor with CNC milling and on the lathe. So the reason being that it's a regeneratively cooled engine, which means that we recycle the fuel in cooling channels around the chamber.
So basically, in the walls of the rocket engine, there are channels where the fuel is being led.
Yes. And this absorbs a lot of heat from the chamber, which is important because otherwise the temperatures in the chamber would be too extreme for the chamber material, and it would melt completely.
And in return, it also heats up the fuel, which makes for a more efficient burn. So that's very nice.
And the fueling channels, it's such a complex geometry that we need 3D printing.
It's just necessary. There's just no way that it would be possible to make this kind of complex structure without 3D printing it. Yeah. Oh, thank you for a lot of Spanish here. It's pretty fantastic, yeah, for sure. Thanks, Liz. We think it's fantastic too, for sure. It's we at a hot fire once we had a camera pointing at the sorry. Homemade rocket engine, well done. Yeah, thank you. It's we didn't 3D print it, but we had someone 3D print it for us. But it's designed in-house. Yes, that's pretty amazing. Lots of
just to briefly
calculations on it.
Explain like how this sort of metal 3D printing works. It's a bit different from like your standard desktop plastic 3D printer.
Of course.
Now
we're sorry.
Oh. The curves of how the rocket behaves were basically flat. That's exactly what you want. It's very stable on the The issue we had earlier today was the Teflon tape getting stuck in the eject fueling valve. And now propagated to the engine, or at least the 99% because we don't see the oxidizer that we expect to see when the engine is running. So we can do two things: keep making long burns, and most likely not solve the problem, or we can spend an hour and a half, disassemble the engine, clean it of all of the gunk that's stuck inside it now. Now we have a filter installed so the gunk won't redeposit, and then we can resume. And we're going with option number 2, because the goal here is to get off the launch rail in Portugal. We don't get off the launch rail in Portugal if the engine is not performing. And then we might land another 2 birds after.
Okay, I don't know if you guys heard that, but just to recap, we need to clean the engine before the next burn, so it will be a while before the next burn.
It's like 1.5 hours.
Yeah, 1.5 hours at least to clean the engine, and the reason being, how to say that mildly?
Basically, it's the problem that we talked about before that we had while we were tanking nitrous oxide, that we had gunk and impurities,
things we don't want,
from the nitrous oxide bottle entering the nitrous oxide line and the check valve. But now the gunk and the impurities have also propagated to the injector and might have clogged some holes in the injector. So what we're doing now is that we're
Can you explain what an injector is if people don't know?
Yeah, so the injector is a plate with a lot of small holes in it that sits just above the thrust chamber where the actual combustion happens. So basically
it looks like a little shower head.
Yeah, it looks like a little shower head. So basically the fuel and the oxidizer comes in and enters a manifold above the injector, and then it's sprayed through the holes in the injector. So it's mixed really well in the combustion chamber. But now we're taking apart the engine so we can clean the injector and get rid of any impurities and gunk that's deposited itself. And we've also installed a filter in the nitrous oxide tanking line, so we won't have any more gunk and trash passing into the fluid system.
So even though it will take a longer time, it's worth it to clean it off and get a more optimal burn. What was I supposed to repeat, Nils? I'm sorry. I'm not sure what we talked about when you wrote this question. So if you could just ask your question again. High flow shower head. Yeah, I don't use it as a shower head though, but it kind of looks like it. Yeah. Prototype rocket motors. We tested 2 prototype rocket motors before this one. We've made 4 rocket motors in total. So the first one was our demonstration engine, was basically a copper block that we didn't ever have any intentions of putting that in a rocket, but it was good for testing and to get some data out that we could use to make the actual engine to be in the rocket. And then that didn't make it in the end, so we had to make a new prototype that we call Engine B. And we have all these videos both on our Facebook page. I think we have some of them on our YouTube here as well, of the engine tests of both the demo engine and the Engine B. Engine B was a throatless engine basically, and that was not supposed to be in a rocket either. But it was also good to get some data out. It resembled the current engine a lot more. And
it allowed us to test the test stand, so that all the plumbing that sits behind the actual engine, Engine B used a similar plumbing system to the real engine that we're using now. So testing Engine B allowed us to test the plumbing for the actual engine. That was the purpose of it.
It makes sense not to go offline and back online later, because it can take 1.5 hours at least to clean it.
Okay. Also, maybe I don't know how is the live stream configured, but if we have cameras besides this one pointing to different places, then maybe in the corner we could put up one of the cameras over there.
Yeah. I don't know who's in charge of that, but that would be nice.
Yeah.
It kind of switches back and forth. Yeah, it didn't make it. Yeah, that's a nice way of putting it. Didn't make it. But yeah, and then we had the aluminum engine that is similar to the one that we have now, but the one we have now is in steel. And aluminum is too soft and will melt by lower temperatures than steel, so it wouldn't be able to be actually put in the rocket in the end. So we've tested 3 different types of engines by now. Yeah. Oh, I'm sorry, Nils. We missed your question. If you come to think of it, then yeah, please repeat.
It's really cozy to be able to hang out with all of you guys on the stream.
How do you know that from? I'm not sure what you mean by where do we know that from? Yeah, the prototype testing phase was a lot of fun, but I think we all enjoy actually being closer to the actual launch. Even though the prototype testing phase is fun, we also need to progress in some direction. How much thrust does the current motor produce? 3 kilonewton, I think.
This burn was 2.4.
This specific burn was 2.4 kilonewton. It's calculated to be 3.
It's the injector that's clogged that station.
Yeah. So hopefully the next burn we'll see without the clogged injector will be higher in thrust. So it's about 10 times larger than the demonstration engine we did about a year ago. Okay, a glitch. Yeah. We experience glitches sometimes. Apologies for that. Yeah. It wasn't tiny. It was about this size, I think, and about this thick. But I mean, again, it was a solid copper block, so it was even though it was small in size, it was a heavy one. Yeah. Yeah, the SpaceX. Yeah. They have glitches too. Yeah.
It should be up now. At least there is one camera which is pointing.
Yeah, I see that. Yeah, so if you hopefully. Oh, thank you. Yeah, thanks for enjoying hanging out with us as well. You should be able to see in the top left corner of the live stream a live stream of the pad as well, like the little rocket bay of the concrete. So you can see the guys working on it there as well. We're gonna leave you at some point because I'm sure you don't want to just sit with us and talk for about an hour and a half more. but we'll be back on, of course, when the next burn is gonna happen.
And it's probably gonna be even more cinematic because it's gonna be a bit dark when the next burn comes.
Okay, I see. Right. We announce our tests usually on our Facebook site and on our LinkedIn as well with the link. But we'll try to post we'll probably use the same stream here for the next one. Oh, thank you for the Facebook like. But we'll just use the same stream here. But we'll probably leave because, again, you don't want to just sit here with us for the next hour and a half. But you can still see, you know, what we're working on while we try to clean the injector. Yeah, thanks for your support. Yeah, it's evolving fast these days, for sure, this project here. Thank you so much for the support and the kind words. We appreciate it. All the hard work is it's not coming to an end because it's not like we're just going to be done with rockets forever. But this project specifically is coming to an end, and it's a weird feeling. Yeah. Now, Copenhagen's Orbitals pops up. Our good friends. We try to shout out each other when we have something interesting to say. I don't know if you know this, but we're actually right next to their headquarters. So this is where they usually test their stuff as well. Yeah, it's the beginning. Yeah, it's the end of Dragonfly project, but I guess it's the beginning for all our careers within rocketry and space industry in general. Yeah, I think great things are to come as well, especially in 2 weeks in Portugal. Hopefully we'll be able to live stream from there as well. We probably won't be able to sit and chat with people, but we can hopefully live stream the launch itself, because that would be pretty spectacular too. Yeah.
And also the fact that the European competition in Portugal is now a thing, that's huge for DanSTAR and the future of DanSTAR, because now every year we can look forward to a new competition which we can participate in, and we can build new rockets every year for that competition. And logistically speaking, it's much easier to get to Portugal than it is to get to
what would be Portugal? Yeah, so as I mentioned earlier, I don't know if you were here, Nils, at the time I withdrew your message, but in Portugal we're going to launch the rocketry competition because our original competition in the US, Spaceport America, got cancelled. Like I mentioned, like everything else fun this year has been cancelled because of this virus going around. But cancelled, unfortunately. And we talked with other European teams about really wanting to launch our rockets this year. And especially because getting to the US is extremely costly and logistically very difficult. Bringing a rocket, like basically a missile, into the US is pretty hard. So driving it to Portugal is a lot easier. So in that sense, this first time that we have this European competition will hopefully not be the last. If there aren't any other questions right now, I think we'll leave you guys. We'll put the stream. Yeah, get back to meet space. Yeah, thank you. Yeah, take care as well. Thank you for tuning in. We'll put this stream in mission control instead, and we'll check back with you in about an hour and a half. So hopefully we'll do another burn about an hour and a half with the injector. Okay, thank you for tuning in.
Thank you for watching, guys.
And we'll tune in later. Thank you for the wishes of luck, of course. See you later. Yeah. Jeg tror ikke, det er starter med. Det er bare for at vide, at det er sådan. Okay. Det må være ud af.
Do you know why Nikolai needed the battery?
One more time?
Do you know why Nikolai needed the battery?
Nope. I should just ask.
Yeah.
Den lurer også. Jeg synes, vi har været spændt hårdt for her.
Det var en meget sjov ting, som gik op for os. Oprindeligt så var det jo designet sådan, at der gik et stykke rør fra brændstoftanken ned til
motoren.
Ja. Men det var ekstremt svært at få den.
Ja, nu er det sådan flexi.
Ja, nu er det sådan flexi, fordi at det var muligt at skære det i den rigtige længde, til at det kom til at passe. Så det bliver nødt til at være flex.
Gør man også i biler. Og, altså for eksempel nogle inline 6 motorer. Så har du udstødningsmanifolder på 3 af dem. Og så har du et flexi joint imellem. Så ligesom sådan at få det tæt. Nogle gange, altså du har... Hvad siger du? Jeg kan godt lide at have haft den fremme. Hvis det hedder weight reduction. Ja, der er ikke også en masse andre bånd, I lige kan gøre det her med. Men ja, her.
Er det lige motorbeslaget?
Det er en del af raketten. Det var en del af raketten. Needs must. Hvor der handles, der spildes. Det er sgu lidt skævt.
Vil I lige hjælpe med at flytte tilbage? Hvor vi har kørt det. Kan I hjælpe med lige
Hej Nikolaj! Sker der der? Det går hurtigt, hvis det er.
Hold kort. Hold man. Nej, det er det igen. Hold.
det smelter helt. Det er helt rødt.
ligner et hus, det der.
Jeg har ligget 2 gange.
Der var nogle flere eller noget.
Der er også de lyseblå der.
De lyseblå.
Fandt sagt. Der skal ikke være lyseblå.
Det er til lampe, nej, det er til loft. Der er ikke nogen lampe.
Og det er Lodde station nu.
Okay, så
det er Lodde station. Det ligger ikke der nogen i.
Okay, så vi har ikke mere end 2 eller?
Vi havde 2 mere et eller andet sted. Men hvor fanden de er blevet af?
Ligger de bare gemme sig til?
Nej. De kommer med sådan en grå låge, så du er nødt til at finde, hvis der var. Det er ikke den der. Det er det ikke der. Peter. Det er bare oscilloskopet. Så ligger der muligvis en topsæt. Det kan være, der ligger noget. Så er det lysmast.
Sebastian? Sebastian? Vil de gerne have en igniter deroppe?
Hvad?
Vil de gerne have en igniter deroppe?
Der ligger en igniter der. Jeg kommer nu.
Okay, han kommer. lang tid det tager at udskifte tempo.
Virkelig. Okay, over halv skulder. Det er ikke
Really?
Der er stadigvæk folk derinde, der lige overhenter.
Det er mig.
Electronics go!
Electronics go!
Head go! Igniter go! Go!
Måske I filme den der derfra, den her retning.
Jeg er ikke færdig.
Nej, skulle vi måske filme den her i den her retning? Okay.
Clear go! Go! Safety go! Safety go! All go! Der er nogle ting allerede, vil jeg sige. Pressurization! Clear. T-minus 16! 10, 9, 8, 7, 6, ignition, 4, 3, 2, 1.
Jeg tror, det er betonskøj.
Det ser vildt af det der sten på højden.
Jeg tror, det var meget beton. Det ser nice ud. Spørgsmål om. Eller der var bare bremsen stor her. Er det
Nej, det er bare sluk på den op. Jeg tror, der er rigtig mange.
Sten er der ikke.
Det er lidt glemt. Lad os gå ud der. Ja, det er lyde over. Lad os gå ud der. Det er nok, at du får sluk på undervand og lave visual inspect. Når du 25 først, så får du fuldstændig ud, og der er ikke så meget som stikplads. Så ser du måske lige mere. Det kan gøre det. Det sidste lige sådan, fuck, et lammehav, mand.
De er godt. Jeg skal sige, jeg synes, vi skal holde dem lidt mere om aftenen.
Ja, det er vildt.
Jeg synes, det fede på stream, det er lige nu, der kan man se stack på streamen.
Ja, det er ikke en
Ja, det skal rigtigt.
Vi laver lige bevis.
Se, det er bare hjertebanker.
Den kan du konstatere det igen. Nej, det er ikke rigtig
Jeg synes lige bagefter, tænker der er mange
Steffen, der lige løber der.
Det her, det var jo et festbeværker i flyvende.
Ja, det var ret.
Ja.
Der er jo ikke til at lukke efter de har klinet det her ud. Det lader sig til det.
Hvad nu? Er der noget styr fast?
Nej.
Nå, okay. Jeg tror måske, vi skal overveje at komme med det. Jeg var ikke så inde at finde. Jeg får lige lov til at finde noget.
Som jeg så prøvede i og det overlevede igen. Så det var helt tydeligt.
skabet, altså navleprækken faldt ud, men det er nok, fordi den der, den kæde, eller hvad? Ja, så der er ikke, der er nemlig ikke noget der, fordi det er det samme job. Det er design. Det var det. Det var det var brug. Hvad siger du? Jeg gik lidt af, så hvis vi læser ud af 3,5, så får den altså røvhul. Very fuel rich.
til Jakob, hans filter virker.
Hans filter virker.
Så langt så godt. Jamen det var så lidt for
Just there.
Ja.
Du kan tage. Det er stort.
Er han skarp? Jeg tror jeg var skarp. Der er lige kørt rundt. Hvor er jeg så henne?
14-8 her, og så helt tryk. Jeg tror herfra frem, så er det bare alle afsnit. Alle kan bare med. Jeg ved, hvor jeg skal være.
Nå, jeg forstår. Men...
Skal du være skarp i det? Jeg skal have telefon, så skal jeg ikke. Der har du en chance. Mad og toilet, så er det. Nu skal du ikke se, nej, jeg vil ikke. Get out of the car! Oh, out of the crowd! That's behind your back! Walk slowly towards my wife! That's so American.
Yeah. I mean, like in America, they can pull a gun on you if it's speeding and they want to pull you over. They can find out it's kind of station to the. And like, yeah, I feel the same way. You don't know what to take a shot under there.
Hey, please.
Yeah.
Okay, for fun.
Nitrous complete. Nice. Gode vinkler, gode vinkler. Efter I er færdige med at montere skidt, så vi har rettet kamera, så skal I tjekke connection på navlestrengen.
Jeg har lige indset, at det er hårdt at stå op.
Ja, vi er resten af sådan dark.
Jeg har aldrig formået at Kun en. Halv kasse.
Hvem mangler det?
Husk, at I skal tage en ignitermåling, inden I går ned. Jeg lige godt stille på en stol til, som du bare kan se med.
Næste gang skal vi have fjernsyn her.
Ja.
Det kunne man da. Man sidder her og venter på, at der sker.
Det er bare det med mikro.
Ja, så kører den.
Ja, tak. I kan se med på sang. Det har vi I helt 100 på det, der sidder godt i.
Dem der lavede en video, der de får bevilget.
Der er lige delay på 20 sekunder.
Over kablen. Før, den overlevede.
Nej, der er 20 sekunders delay på livestream. Ja, det er great. Der går lige en 5 minutter. Hey, we say that. Yeah, exactly. So we need to add like
Who's scouts this time around? Who's scouts? Victor, Jonas, Hasse, Steven, Oliver. You go where? Same as last. So
Jeg går herover.
So Oliver, you get the road. Who got the path in between there? You take that one. Victor, you go down there. Hasse, you got the road over there. And Jonas, I've got over there. We got this one over here. Yeah. And we have already cleared the area with the lights. Yeah. So we don't need to do the back trip. We have the bike. So, you're free to go.
Yes.
Roll out.
Altså, hvor til det klokken halv 9 om aftenen. Vi ses. Ja, it's fine. We have a bunch of people from different time zones. Probably, according to all vi har nogle meget tekniske spørgsmål, som jeg ikke kan svare på. Vi har brugt nogle maker. Spørg, hvordan vi får plads.
Ja, har vi nej.
Det går til. Gør på livestream. Du kan lige svare på, hvordan der er mæk-spørgsmål.
Hej. Hej. Hej Dylan. Hej Jonas. Hej Hasse. Hej Oliver. Hej Victor. Oliver, are you in position? Are you in position?
Not my department.
Even are you in position? Victor, are you in position? Okay. Hasse, are you in position? Ah, you need to. Jonas, are you in position? Let me know, Hasse and Victor, are you in position?
Hvorfor lige et spørgsmål?
Hasse and Victor status? Hasse and Victor status? Ja, modtaget.
Oh my god. Tak. Jeg har lige spurgt om det mærke.
Electronics go!
Electronics is go!
Head go! Head go! Igniter go! Oliver go! Oliver go! Steven, you go! Victor go! Hasse go! Jonas go! Tobias go! Go! Safety go! Safety go! All go!
Input.
Internal power! Pressurization! Pressurization complete! T-minus 16!
10, 9, 8, 7, 3, 2, 1.
Sebastian, telefon!
Ja, så er med på videoen.
Ja, Sebastian! Hvor er Sebastian? Hvad sker der? Jeg skal have en fucking lys, man. Hvad er det eneste, jeg har aftalt? Sebastian?
Det er betonklokken, der...
Vi ringer til Sebastian, Stefan. Vi ringer til Sebastian. Ja, tak. Holy shit, der er ikke noget. Det er bare Sebastian, der besluttede det der. Efter lige at have lavet en aftale med selv.
Straffet, ikke?
Var det bare det?
Var det?
Ja, det var også det.
Var det?
Er I skuffet, eller?
Ja, men jeg er overrasket. Min telefon slukkede, og min slukkede, hun er den eneste, der
Nå, så er det fordi, jeg har gamle batterier.
Men, ja, men
det er svært at fange på film. Ja, det er rigtig svært. Du kan ikke rigtig skal den kamera, der ligger derude. Men det hele er livestream, så du kan faktisk finde det på Facebook.
Og det kan du ikke vise det med Facebook?
Ja, jeg har lige set det her. Ja, det har jeg lige set.
Vi kan komme op lige her. Så vi lige er ved at sige.
Jeg har ikke en telefon, hvad der er noget. Vi ringer lige til Peter.
Ja, tak.
Peter hvem? Jeg ringer lige til Peter.
Hallo?
Kend her målscore.
Nice.
Det er
man tager lige CO2 med rundt.
Der er stadig hele kabel, men så er der lidt vildbånd omkring raketten efter, som vi skal slå.
Held og lykke med det. Ja, det kan jeg godt. Det kan jeg godt. Nå, held og lykke med det hele. Tak for det.
Jeg kan ikke se helt i noget mere, så det er beton, det skjult gennem. Hvis du træder rundt om, så laver vi lige et break.
De der piger der, de kører lige ud her. Ja. Og der kommer nogle piger fra den modsatte side af dig, og de vil gerne lukke igennem.
Du vil gerne tage sidst af passen og vurdere om ja.
Ja, Peter. Jeg har skulle have været telefonnummer.
Hat clear! Det er ikke kommet ud lige. Nu kan der med. Men vi vil gerne
Så har vi fået gået ned.
det er lige Scout, you can come back.
Så ligger den altså ret tæt på, fordi den ligger deroppe.